Good morning, or good evening, whenever you're listening to this, I guess. Um, we're going to do our last lesson of this unit, and it has to do with a thing called sigma notation. So you're going to want to get your notebook out and take notes on this, and always go back and review something that you don't understand. Um, sigma notation is based on that symbol. That symbol is sigma. It's a Greek letter. And for math, you should always think of sum. So that's the sum of some terms based on some other things. So when you're looking at sigma notation, if you don't know what is being displayed, it can get kind of confusing. So the sigma stands for sum, and then right underneath it, you'll see a letter, an index, and then some sort of a starting value will be in this box. Some sort of an ending value will be in this box. And right after the sigma, you'll have some kind of rule. So when you think about like what you have here, let me write what everything is. This is the index. Some people might even think of this as the variable. Okay. This right here is the starting value. So the starting value for the index. This up here is the ending value. And in this box is some sort of rule that you would follow. So if I wrote an example and I said, okay, let's look at this. Let's look at this using, what if I give you an example with all that stuff in there? How would you use it? How would you interpret it? Now, a lot of it has to do with whether or not you understand what the pieces are. So I think I got about 5-6 examples here. Example 1. If I said write out the following, so write out the following. And what I gave you is I said we got summation, that's what sigma is, summation from n equals 0, so that's where we're going to start n at 0, to n equals 5, and the rule we have is just 3 times n. So there's our sigma notation. So we're going to start at 0, we're going to go to 5, and we're going to use the rule 3 times n. If you kind of understood what the notation was, that means this would be 3 times 0 plus 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. And right there, we're done with the problem. And then if you really needed to add that up, you could. One of the things that you should look is if you have the Desmos calculator on your phone, what I would encourage you to do, let me just get my phone and make sure what I'm looking at. But on my phone, the Desmos calculator, if you go under functions, so that stands for functions, and you go to MISC, you'll see a sigma notation right there at the bottom. And when you touch it, it actually puts everything right in there for you, and it uses n as the index. So it's really perfect. It's already set up for you. So if you're kind of wondering, how do I do this? How do I not have to go in there? That's what you would do. You use your calculator, because ultimately these things can get really large, but that's how I would encourage you to complete this problem, if I didn't say more than just write it out. But that's clearly not all I'm going to ask you to do, right? I mean, I'm going to ask you to do an example, something like this one. So we'll call this example 2. And I'm going to say write in sigma notation. And maybe I do something really easy. 1 plus 2 plus 3 plus, and it's going all the way up to 10. And if I look at the pattern that exists, each time I go from the next one, we go up 1. So each time we go up 1. And really, if we think about it, all we're really doing on this is we're starting at 1, we're going up to 10, and we're putting n in there. Because if we think about what that looks like, if we go back to our first example, what that would mean is we put 1 in, plus 1 we put 2 in, plus 1 we put 3 in, and so on. And so that's our answer. Hopefully that makes sense to you. So let's look at maybe a little bit more challenging one. So example 3. And again, write in sigma notation. And what we're going to write is we're going to do 2 plus 4 plus 8 plus all the way up to 64. So when you look at this one and you kind of go, okay, well, what's happening each time? It looks like every time we're multiplying by 2. You think about these are powers of 2. Looks like these are powers of 2. And so you know that's going to be the rule, right? I mean, that has to be the rule if we're multiplying by 2 each time, and that's our rule, and that's where we're going to start. So we're going to kind of say, okay, well, then our sigma, we can still start it at n equals 1. Let's figure out, we'll fill in this top piece in a second. We'll talk about what that is. But our rule is really 2 to the n power. Now comes the question of, what is that top value? Well, you think about it, there are some missing pieces in here. Missing in here would be 16 and 32, right? Those two pieces, 8 times 2 is 16, 16 times 2 is 32, 32 times 2, then you get to 64. So now if you count how many of those we have 1, 2, 3, 4, 5, 6. So if you think about what we have in there, we have 6 terms. That means if we start at 1, we're going to need to end at 6 up there, and then we have the solution. So that's example 3. You can pause it and take a look at it and see what it looks like. Okay. So now I'm going to have you do two examples and allow you to pause the video and then see if you can write out what it does to the same kind of thing. So first one, so example 4. and then we're going to call it you do. So you're going to do it first, and it's going to be write out. Sometimes that's called expanding. So write out or expand summation n equals 0 to 4. Actually, let's make it 3. We'll just make you do a couple of them here. 2 times 3 to the n. So I'm going to give you a second. Pause the video. Write it out. And then when you're done, come back and hit play, and we'll get started again. Okay. So you should be back here, and I'm going to write it out now. So if I wrote it out, the first value would be 2 times 3 to the 0 power plus 2 times 3 to the first power plus 2 times 3 to the second power plus 2 times 3 to the third power. You notice that index goes up by 1 each time. And because it's a sigma, that's where the summation comes in. And you can see we started at 0. We ended the index at 3. And then we just used the rule. And if we went further and we said, okay, well, what happens with this? This is 2 times 1, because remember, anything to the 0 power is 1, plus 2 times 3, plus 2 times 9, plus 2 times 27. Now, if you had to do this by hand, that'd be 2 plus 6 plus 18 plus 54, and so on. Maybe not super handy, but Desmos could certainly do that. I'd encourage you to type that into Desmos. It's a pretty easy thing to do. Again, you would go to Open Desmos and go to Functions, go to Miscellaneous. Right there at the bottom in the middle column is the sigma. And we would start it at 0. We'd jump up to 3. And the rule that we would put in is 2 times, remember to go to the keyboard and put n. 2 times 3, 3 to the put an n here, and you should have gotten 80 for a result. Sorry, I was bumbling around on my own keyboard. But you should get 80 for a result. And if you had added all those up, you'd have gotten 80 anyway. But either way, that's where we are. So last example. So this is the last example, then you'll get to go to Delta Math and do some work. This is example 5. And it's going to be write in sigma notation the following. 2 plus 5 plus 8 all the way up to 17. So I'm going to give you a second, kind of figure out what's going on here to do this, and see if you can, so pause the video, see if you can do this on your own. All right, if you're back, we're going to get started. If we look at what's happening each time, starting at 2, so here's kind of where our starting value is. And it looks like we're going up by 3 each time. Up by 3 each time. So the piece that's missing in here would be 11, 14. Then we finally get to 17, right? So if you think about, what's happening is we're going to add this, we're going to do a summation. So this one, if you go back and you think about what this is, so we've already kind of talked about this, but this is an arithmetic sequence. Because we're adding it, it's also, you might term it a series. And so we're adding the same amount each time. So when you think about what's happening, we're adding that 3. That 3 is really our slope, if you think about like a slope in a linear equation. And what we have here is we're going to start n. I'm going to start it at 0. And we're going to do 3, which is our how much we go up each time, times n, plus what we originally started with, which is 2. And if you think about how many terms we have, I highlight them, 1, 2, 3, 4, 5, 6. So again, in this one, we got 6 terms. So that's where we're going to put a 6 right there at the top. And that would be example 5 written out. Hopefully you have that. It's now your turn to go to the next slide. Go to the next slide in the HyperDocs. And do the Delta Math assignment. Okay, so go to the Delta Math and do the Delta Math assignment. Again, you can always check in with office hours and get help when needed. See you next time.